So let's talk about mean value theorem. So what it basically means is that if we zoom in on an interval over a function, then the instantaneous rate of change should equal the average rate of change. Keep in mind that the function should be continuous and differentiable over the interval. So in unit 5, it talks a lot about maxes and mins, and basically there's a rule for that called extreme value theorem. And basically what it means is that for a function on an interval, there's at least one maximum and one minimum, and the function has to be continuous as well. Now we can find these maxes and mins using critical points, and to find critical points, you just have to find the derivative of a function and set it to 0. We can use the derivatives to see what the function is doing, whether it's increasing or decreasing. If we look at a critical point on the graph, then we see that the derivative of the function crosses the x-axis. Now if we want to see what the function is doing without a graph, we can use the first derivative test to plug in numbers on a number line next to the critical point. You can also plug in critical points into the second derivative of the function to also find the local maxes or mins. If we want to find the absolute maximums and minimums, then we can plug in our critical points and the endpoints onto the original function. This is known as candidate's test. Now we can also use the second derivative to find inflection points, and what inflection points are is it tells us whether or not the original function is going concave up or concave down. We can put the inflection points on a number line to find out whether or not a function is concave up or concave down. And that's it. Hit the like button and subscribe.